Hello and welcome to part 7 of Dev Maths and Stats Refresher Course, Lecture 6. So now we're going to look at how you can use Excel to check the rearrangement of equations. So here we've got an equation, so h is a function of r and g, which you could write like this. You can see that this equation is then put into this like that. So any value of h is equal to 4 times the value of r plus 11 times the value of g. And that works for any value of r and g. Yeah. So these I can change anything I want to here. But what I want to know is it possible to rearrange the equation so that g becomes a function of r and h? Which means that if 2, 7 gives me 85 here, that means that if I put in here 2 and 85, I want a function that takes me back to g, the correct value of 7. So something that undoes the function that gives me back g again. So in other words, I need to rearrange this to make g the subject. So it's just a bit of a revision of basic math. So obviously we need to rearrange this to make g equal to h, which minus 4r, and divide by 11. So h minus 4r divided by 11 should work. So you have to be able to put that into that cell. So h minus 4r 11. Unfortunately, as soon as I start typing, that disappears. So equals h minus 4 times r, which is going to be here, divided by 11. Not very happy with that. What did I do wrong? H. Okay, I'll just put H. H has to be this. Okay, so that's it takes back to 7. So this seems to work now. So anything I put in here, you see 2 and 7 went in, 85 came out. Put in the 85 with the 2 and get back to the 7, and just make sure that works for anything. Any possible numbers I put in here. So I'll get that. Minus 891, and the 11 gives me back to this. So I put 2 numbers in here and it gives me back the g again. So that seems to work. So I've rearranged the equation correctly and I've entered it into Excel correctly. Very good. Okay, so could you rearrange this so that n becomes a dependent variable, then create further rows to allow you to check the rearrangement as before? So let's just do the, let's put this in first. So a nice thing you can do is just copy the whole of that, stick it into here, and just rename everything. So you're looking at v as a function of m and n. So there will be m, n, and that gives me v, v as a function of n. Oops. And then I want to rearrange that. So if I put in m and v, it should correctly give me back the right value of n. N then will be a function of m and v. But this is not the function I want. I want this function here. Get rid of this. Never mind. So your first job is to put that in here. So equals for a function v, of course, m. So a bracket sqrt. That's the square roots. Then a big bracket, and then 3 times m to the power 2. M is this one. Power 2 minus 16 times n is that one, close brackets, and that should be about right. Okay. Yeah. We need to unpick this. So let's just show the steps just for I am going through at a slow pace, so I quite understand people want to skip ahead. This is a kind of getting people to catch up and not get too left behind kind of lecture in many ways. So I'm going to rearrange this. So first thing I want to do is to square both sides. So we're going to go v squared is equal to 3m squared minus 16n. Square both sides, and then maybe we would, what are we trying to get? M of, we're trying to get, that should be m and n. That shouldn't be. We're trying to get n on its own, yes. Bring n, add 16n, subtract v squared. So 16n comes this side, v squared on this side becomes negative. So n is 3m squared minus v squared, all divided by 16, hopefully. So 3m squared minus v squared over 16 equal to 3 times m to the power 2 minus, I think you've gotten minus what? Minus v squared. V power 2 divided by 16. So that's promising. What's gone wrong there? 3m squared, v is 3m squared minus 16n. V squared is 3m squared minus 16n. V squared is squared minus v squared. So n is 3m squared minus v squared of 16. So it doesn't look very good, but then that's probably because I need to, the output from v here has to go back into here. So here I can either just copy this to here, or I can cheat and put a link in like this. It just picks up the value from there. Yeah, and that seems to work. So you put these into the function that comes out here, into the function v, and then you put m and v back into the function here, and you get n coming out like that, back to 85. So that rearrangement has worked, as you can verify the rearrangement using Excel, like that. Okay, so let's see. Solve some simple equations next. First of all, just one very, very simple equation. So just to get the principle across. So if you have a simple equation like this, equations 1. So you just want to find an unknown that makes this equals this. So you can set it up like this. So that's got this equation here, that's got this equation here, and it's just by trial and error you can find a solution. Okay, it's 6. We can do it by rearrangement. Okay, so you can rearrange, or you can just do trial and error. So the answer is 6. So that's the principle of it. But it's more interesting when you go on to simultaneous equations. So for simultaneous equations, you have to have two unknowns set up like this. Here's the equations you're going to want to have in, and here's the test to see if it works. So that's the top equation, and that's the bottom equation. So that seems to, at the moment, these are not the correct solutions to these. So you can see this doing 12 times this plus 3 times this, that's the top row. And the bottom row is 2 times that minus 4 times this. And it definitely, they're not equal at the moment. So we need to find a solution and then check the solution works. So I'm going to use this as an opportunity just to do hand demonstrations of some very simple inverse matrix and Cramer's rule again. So if you want to see the inverse matrix and Cramer's rule again, I'll demonstrate that now. Otherwise, please skip forward. So I'm going to take the equation we're trying to solve, put it on the whiteboard, which I think I've forgotten to clean off. Indeed, it's a lazy person. Oops. What the equivalent of cleaning the whiteboard for a teacher is on these things. We used to have to do that at school. So to solve this, let's do the first one by a matrix method. So you might have 12, 3, and 2 minus 4, so by the inverse matrix method. Must be equal to 18, oops, 30, like so. I wish your pens were so easy to erase. So 12, 3, 2, negative 4 is 18, 30. So to solve it by a inverse matrix, if this is matrix A, then U V is going to be inverse of matrix A times 18 over 30. So inverse of matrix A, I'm going to need to go get the determinant of A. So that's going to be negative 48. Oops. Negative 48 subtract 6, which is going to be like negative 2. Negative 42. And then here, rearrange these things. So you have negative 4, 12, negative 3, negative 2, times 18 and 30. Like so. Negative 42, negative 4, 12, minus 2. Okay, that all seems fine. So now you just have to do the calculation. So minus 1 over 42 times, okay, the result there. So because it's 162, and also notice that I got these negative numbers wrong here, because this is minus 48 minus 6 is minus 54. I added instead of subtracted. Always make mistakes with negative numbers. Okay, so let's see. I hope this divides by 54, and then, as it does, 3. And then the other one is 3, 2, 4. So 3, 2, 4 divided by 54 is 6. So you get 3 and 6 as U and V, which brings us to the moment of truth. That's going to be wrong because there's a negative sign here. So hopefully it's going to be negative that. No, I think again I made a mistake because this was negative. And that was all negative. This must have been negative 162 divided by this, that's positive 3 there. Oops, sacrifice that. And this was very positive, that's positive, so that will be negative 6. So 3 and negative 6, that's interesting. Let's see if that's actually right. Yeah, okay, so you get 18 and you get 30, which is what you're required to get. Good, so those are the solutions. Excellent. Back to here. Okay, so that's using the matrix one. Then let's set it up for these two here. To modify the spreadsheet, so let's check these solutions. So first of all, let's try this one. first of all put it here perhaps. Cover that over there. Pretty dumb, isn't it? Okay, you get what I mean. That's going to be the first one. So this is going to have to be 2u minus 6 times v, and this one's going to have to be u okay, I need to rearrange it. So it's u minus 8v equals 3. So I need to rearrange the second equation so it's not quite so silly to have that there. So what you really want is to rearrange it. You have 2u minus 4 minus 6v plus v equals 46, and u minus 8v is got v equal to 3. I need to move the constant to the right hand side. So that's the equation we need to solve. Let's just go over to the whiteboard. Go in the question and solve. Let's do a Cramer's rule, because people seem to be getting more confused by Cramer's rule. Sorry, somebody, I'm not the only people doing maths, my daughter is doing maths homework as we prepare this, and that's her homework printing out, I think. I'm not printing it if you can hear in the background, sorry about that. So, let's see if we can do this by Cramer's rule. So the matrix would be A times UV is equal to 46 and 3. Yeah. So move the constants to the right hand side, and then the coefficient, the actual matrix A is then equal to 2 minus 6, and then 1, and then we move this to this side, so minus 8. So 2 minus 6, 1 minus 8, that's equal to 46 and 3, like this. 46, 3. So we should be able to get the value of u using Cramer's rule by looking at the determinant of the matrix sometimes called A1, where you take matrix A and you replace the first column with 46 and 3, and then divide that by the matrix of the determinant of the original matrix, 2 minus 6, 1 minus 8. So here we find 46 times negative 8 minus 46 times negative 8 minus 18, so plus 18 comes to 350, and negative 16 subtract negative 16, actually add another 6, it's negative 10, should be negative there, and that's negative 10. So finding positive 35, that one, for U. And for V, it's matrix A2, which is 2, 1, 2, 1, then replace this with 46, 3. divided by the same thing, negative 10 again, the same determinant here. So we find this time, so it's going to be 6. 6 minus 46 is going to be minus 40. So minus 40 over negative 10 is going to be plus 4. So I'm looking at 35 and 4 are my candidates. So let's see if we have disaster or joy. Looks pretty good. 46 and 3 we get, so bingo, so that works. So another one chalked up for Kramer, and there we go. So I was going to say I'll stop now, but I won't stop now. Please, I'm going to do yet another Kramer. Please fast forward if you really can't stand another Kramer's rule. I'm just doing this for people that feel they need another bit of practice on that. So last example is this one. Oops. Actually in here. Oops, I have to come like this. It's the new equation we're trying to satisfy. So this time we've got I'm trying to fulfill 17u plus 4v equals 6. 17u plus 4v equals 6 and 3u minus 24v equals 12. U plus 4v is 6, 3u minus 24v is 12. Okay, let's just take that to the whiteboard. So from this we can write down the matrix equation 17, 4, 3 minus 24. So u is going to be equal to 6, 12. This, but it's this first column for negative 24 divided by this determinant. And then v is going to be 17.3 and 6.12 put on this side divided by the same determinant on the bottom. 74, 3 minus 24, 74, 3 minus 24. 24. Okay, so I just be lazy and reach for the calculator and work those out. So calculator gives minus 192 over minus 420, I think, minus 420. And positive 186 over 420. No, negative. Yeah, over negative, yeah. Okay. So this is 192 over 420. So let's just, I mean, these look quite unlikely to me. They're very strange decimals. So perhaps there's a mistake, but let's see, equals 192, wasn't it? Divided by 420. And this is going to be equal to 186 fraction is the one that's negative. Equals negative 186 over 420. Okay, so this looks wrong. 192 over 420, negative 186 over 420. Oh yeah, I've got to change these to the right coefficients. So this should say 17 times u and 4 times v. So that's going to come out correctly. Plus 4 times v. Oh, 6, okay, it works. Let's do this one. 3 times F3 minus 24 times 12. Okay, so it does work. So these are the correct solutions. So obviously much nastier solutions here, but you correctly get them with the Kramer's method. So good old Kramer wins again. Good. So well done Kramer, well done Excel for checking that. Oh, we got the wrong spreadsheet. There we go. Okay, so in the final part of the basic maths part, I think it's the final part for now, we'll look at percentages, compound interest and time discounting, which is really handy from personal experience.